Oh, welcome back to Science Sunday, everybody. Glad you could be here to join us today. Today we're going to be going over some of the home science fun that both SciStrike and myself have been concocting. So, welcome to a high voltage Science Sunday. There's only so many ways to just outright say it, but yes, we are finally doing some high voltage, mad scientist awesomeness.
Indeed.
So, if for anyone on G+, I'm sure you've seen the multiple different experiments that both SciStrike and myself have been building and tinkering with, and the latest of both of our projects have been Tesla coils. I mean, why not? It's like the coolest high voltage thing you could ever concoct. So I was going to fire mine up today and have some sort of an issue with the neon sign transformer that I'm using, and its warning LED that I am 99% sure is a ground fault interrupt type device decided it was going to explode and start billowing smoke. So, if you ever play with high voltage, you've probably blown up a transformer once or twice. This is about my third in the last 2 months. I'm not... It's kind of getting agitating, so...
It's part of the adventure.
Indeed. I can't imagine the transformer itself is damaged. It's just something happened, it melted an LED, and now the LED is just billowing smoke. And, you know, it happens.
Uh-oh.
Now,
Andy, you have
does
a
your
question?
homemade giant capacitor have issues with self-charging? Alan, actually, that's a good question. My homemade cap was charging up pretty decently on Friday, and it charged up decently this morning. And then it found a short in itself and decided that it was going to go ahead and melt the plate. Not the entire plate, but it did have it. It found a short. I didn't have it well enough insulated, and yeah, I went from 6 plates to 5 plates. It seemed to be charging just fine until, again, I started another fire.
That's all you need is one arc over, and that'll usually leave a carbon trace, and then carbon traces are conductive, and it all goes downhill from there.
Oh yeah, yeah. I made the mistake. I went with kind of a car battery terminal style design on my homemade cap, so I should have gone with one lead out one side, one lead out the other. This never would have happened that way. Instead, I did kind of a L-shaped design with both leads coming out the same side so that it would be easier to wire, but it also made a arc over very, very easy. So that was probably a poor design to go with, but now that it's insulated better, there doesn't seem to be any issues on that end. Just the burnt out LED bulb that I don't understand, but we'll take the transformer apart here in a little while and figure that out.
Indeed. That's like I said. That's actually part of the fun. If it all went smoothly, where would the excitement be? You're not pushing the edge.
Right? It'd be boring if you sat down and you did all the work and everything was just perfect. What would be the point?
I agree.
You can't learn if something doesn't break.
Well, actually,
if
you
go ahead,
you still have the microwave oven transformer around.
Oh yeah,
because with those you can use those are only a maximum of like 2,000 volts out, but
yeah.
Many people have successfully used them for projects just such as these by making a voltage doubler or quadrupler or etc. With the diode capacitor ladder you make, and you can multiply it as many times as you like by just making the ladder longer. So, if you're having too much fun remedying the transformer that went south, you do have a backup plan over there. I've seen that done.
Indeed. I do have a backup. I am a little concerned about the current from a microwave transformer. That scares me quite a bit, actually. But as long as everything's inside of a wooden box or something to that effect, that's really not that big of a deal.
I would agree.
Microwave transformers do put out a little bit more than a lethal current.
That they do. That's why the last time we talked about this, every time I made reference to I was always saying one hand in the pocket, because that's how you. Yep. Yeah. Your other hand might get RF burn or just a nice high voltage shock, but as long as it's not voltage across your chest, you're getting up after.
Right. So with my, I don't actually know the dimensions on your Tesla coil. The one I wound, the secondary was 970 turns on 4-inch PVC pipe. So that's about 4.5-inch outside diameter on the pipe. In total, it's 22 inches long. The toroid has an outside diameter of about 16 inches, and the toroid's actually a really fun one, because the only way that I could wind up getting something that worked out to hold everything in the right shape and the right size, it happened to be pot pie tins. So I had to scarf a couple of family-sized pot pies in order to make my toroid.
Oh hell! What you doing, Andy? Eating? Why? You hungry? No.
Eating for science.
Eating for science. That is, I could see after you made the actual donut shape for the toroid, I could see you looking at the thing going, all right, now what's going to fit in the middle of this thing to make a nice mount point? And then the idea, pot pies. Well done.
I didn't even think about it until I was just sitting down and eating, and I was looking at it going, that's the perfect size. Everything's right.
And then the realization, oh no, I have to eat 2 of these?
Then 2 of the family-sized pot pies. It took me a couple of days.
Did you mention, maybe you should mention what your actual toroid was fabricated from?
Oh, the remainder of the toroid is made from rigid dryer duct. So it's not the steel wire with, Mylar wrapped around it kind of thing. It's the semi-rigid dryer duct that's just solid spun aluminum. It offers a lot of breakout points, so once everything is working right, the arcs will be very chaotic and random. I'll probably wind up adding a breakout point onto it eventually, but getting everything going, it's just going to leave it as the raw dryer duct, and then, aluminum foil duct tape keeps everything else together. So all in all, it's actually, the toroid was the simplest thing to create out of all of it in reality.
Yeah, winding the secondary is the most fun, though, right? It's a very zen experience.
Oh yeah, it's a blast. I wound up having to wear a wrist brace for 3 days afterwards. I know it wasn't my wrist; it was actually the tendon in my thumb, because I was holding the coil between my pinky finger and my thumb and using my middle finger as a tensioner. That was a big mistake.
Well, what you describe is pretty much the only way to do it if you're winding a coil by hand, and it would kind of take the fun out of it to just order up one of those coil winding machines and have it all done in a minute and a half. That would be cheating. And and we'd be out like $400 for a coil winding machine. So.
Yeah, exactly. I just bought some magnet wire and some PVC pipe. That part was simple.
Indeed.
It is very, very time consuming, though. If you're looking at building your own Tesla coil, start with the secondary, because it's going to be the most painful part of the entire thing, provided you don't, touch one of the arcs once it's running.
Indeed, it won't kill you. It'll wake you up. It'll definitely wake you up.
Oh yeah, it'll burn like there's no tomorrow. I don't want to know what that one feels like.
Yeah, well, see, it's an added. You have an added advantage here that you don't have with, say, the Van de Graaff generator. Van de Graaff generator, you put your hand right on top. You know, it'll arc a couple times while you're getting your hand close to it. And you're, look, it's arcing to me. The Tesla coil has the added advantage of it's operating at radio frequency. So, in addition to being hit by a blast of electricity, you're also getting RF burns in the same area.
Oh yeah.
So. Yes, Jason. Don't cross the streams. That's exactly what we're
saying. Exactly.
Well,
so I know you were asking me what I used for the spacers on my primary, and that's for anyone who hasn't thought about building a Tesla coil or things of that nature. Your primary coil is insanely difficult to actually wind because you want about a 1/4 inch gap in between each winding, and it can be very tricky to sit down and keep that consistent and maintain the right gap width. So I had found some clips through a McMaster-Carr online, industrial distributor, and they're spaced perfectly. They're getting a little bunched up. I have a total of 12 lines on mine, and the clips that I found are getting a little bit tight, a little bit stiff. Everything's kind of trying to buckle, but just with hot glue, they're still staying down and holding everything together. But these little clips made winding the primary so much easier. The first time I tried just kind of freehanding and using little, 1/4 inch rounded staples. It was a mess. It was an absolute nightmare. And these little spacer clips that I got dropped the coil down over the floor mount for the 4-inch PVC pipe, hot glued the spacers down onto the piece of plywood that this is all attached to, and maybe 10 or 15 minutes, everything was done. And these little things were so easy to use. It was awesome.
But your hands were very tired from bending the copper. You have a question from Beach 8.
Oh yeah,
asking if the same wire was used on the secondary as the primary. Oh no, on the vertical coil as on the toroid. I'm not sure what to make of that. The toroid. I think it's asking about
the secondary that the toroid's mounted to. That's wound with 24 gauge magnet wire, and the primary that's down at the base of the whole unit that is the only thing actually receiving physical voltage. It's actually a 1/4 inch copper tubing, so it's not solid wire. I'm sure you can use solid wire, but that would just make your hands hurt 10 times more.
Yes,
1/4 inch copper water line. Soft, malleable copper. It's easy to work with. It clips into conventional size. Those 1/4 inch clips I was talking about, and it's just a lot easier to work with. When I was building my Jacob's ladder, I was using number 4 bare copper wire for that, and it's not fun to work with gauges of that thickness. It's just not fun.
Indeed, but yeah, I use the same 1/4 inch copper tubing. We're not putting anywhere near the current into it that would actually warm up that much copper. We could have used just heavy gauge copper wire, but there are advantages. The tubing is more rigid, and any vibration while it's in operation will make its resonant frequency swing back and forth as well. So it's not just for the current handling capability that we used 1/4 inch copper wire tubing.
Indeed, and thanks for bringing up the resonance, because that's you can hop on YouTube and watch all kinds of things about Tesla coils and people talking about the number of turns on their secondary. how the voltage amplification is done through turns, and that's not entirely true. Everything with a Tesla coil is about inductance, resonance, and making sure that both coils are able to actually resonate at the same frequency. So you can't just sit down and go, oh, I'm going to make 3,000 turns on my secondary and shoot lightning off the ground. It's not going to work that way.
No,
If it was that easy, then I'm sure there'd be lightning machines all over the planet doing this.
Quite true. Yes, resonance is the trick with the Tesla coil. The good thing about it, though, when you constructed one, is even before the the coils are actually matched, it'll do something. As soon as you fire it up, it'll make some kind of output, generally lower than what you'd expect. But that allows you to tune it by changing the clip along your primary to or adding or removing plates in your capacitor to change change the resonance. You can even change the size of the toroid at the top if you really want to get wacky about it. But it'll always do something when you fire it up. So that kind of helps you.
And you can even actually move the toroid up and down, and it changes your arc length just due to its more airspace. I don't entirely actually understand how that one works, but it does work.
Yeah. Oh, look! Did you see Steve Bauman's question?
We will get to the zap. Yes. I guarantee it.
There's zap coming.
Oh,
very nice. And
I should have sent my exploding transformer video to you. That was retarded.
Oh, remember how well the what was it? Oh, from the Jacob's Ladder. Remember the microwave transformer that the smoke escaped from?
Oh, that's the one I was talking about.
Yeah, that one went over very well when we showed it during Sunday Science, if you recall. Anyway,
when you overvolt a transformer, they do have a tendency to light the insulating material on fire.
You'd think they'd have enough sense to make that stuff non-flammable, wouldn't you? Well.
They tried. If there's a way to break something, I will figure it out.
Well, don't forget Edison. Was it 99 ways not to make a light bulb? He learned, he said, or some such quote.
Right? If it exists, I will figure out how to break it accidentally. I swear. I'm better at breaking stuff than I am at building stuff, and I build stuff for a living, so that should let you know how much stuff I wind up breaking.
Indeed. Oh, one should also mention, I guess, if one is thinking of building maybe we'll have a construction how-to for anybody that wants to make their own at some point in the future. But the thing to remember is, if you do, you may, when operating the thing, actually be violating FCC regulations. because it is essentially, I mean, looking at the thing, it's just a very simple, unmodulated AM transmitter, and a rather powerful one at that. So if you happen to have one, use at your own risk, and don't be surprised when you get what's called a notice of apparent liability from the FCC.
Right.
That means
it would be kind of fun to set one of these up next to somebody who's a ham enthusiast.
Oh, indeed. Well, they would. I suspect they would track you down immediately, and then you'd both have a good laugh, because the circuit was not that different for the first hams were using spark gap transmitters, which were very similar to this. All they had was a little extra filtering to try and narrow the output signal around around the resonant frequency. With a Tesla coil, you're just putting out any spike that goes through the thing. But if you did happen to have a ham come by and say what you got there, he'd actually probably be very amused, because it's a piece of history.
It really is. I mean, it's easy to think of all of the amazing things that Tesla really did for the world of electrical engineering, but at the end of the day, he's the father of radio.
Quite true. And let's not forget that handy little AC current thing, so we don't have to have a power...
that thing that runs the world? Yeah, that's pretty awesome.
Yeah, so we don't have to have a power station on every block, and transformers are possible. Yeah, all of those things. Boy, that irked Edison, didn't it?
Oh, yeah.
Yeah.
Oh, it happens. So, since I was not able to get my Tesla coil running today, there are some, I got multiple pictures of it up on G+, things of that nature, but with it not working, it just isn't that awesome. So, Psystrike, I know you've just were able to get tuned into resonance well with yours, so I think I'm going to go ahead and turn things over to you for a little while.
Uh-oh, so we want Zap Zap as requested.
I think it's time for some Zap Zap.
All right, so shall it be. Let us here's what some of the things one can expect from a small to medium size. Oh, and by the way, my second generation coil, I have been outdone by Andy yet again, because mine's only wound on a 3-inch coil, 3-inch coil form. It's still a total of 22 inches of coil on a 24-inch form, but it's only a 3-inch one, so outdone again, damn it! All right, here's some sparks. This is with a breakpoint clip to the outside of the toroid. Electrons love points. If you give it a sharp surface, it'll more easily move out into the air.
So this round of the toroid, what was this one made from?
Embarrassingly enough, this one was made from eBay for $11. So,
that works.
And here's a twisty from a thing of bread doing ion drive in a circle. Contrary to popular belief, it is not heat that is spinning it. It is being repelled from the cloud of ions that it creates itself. Yeah, this is still with the original.
Right.
Alright, I could have clipped this one a little shorter. Sorry about that.
I'm not worried.
I threw it together in a hurry. I'm sorry. And yes, I'm on the other end of that screwdriver. This is the Series 2. It's got, obviously at the moment, quite a bit higher output. This is about 5-inch arcs without arcing to anything, just into the air. So, oh, and I switched to I tried a sphere as well, just to see what the effect would be. Acts about the same. It's it provides the same amount of capacitance. That's the interesting thing. For a resonant circuit, normally a coil and a capacitor together is what you need, and a lot of people with the Tesla circuit, looking at it, let's bring it up here again, will say, yeah, all right, I see a capacitor in a circuit, and I see a coil, and yeah, they're kind of in parallel, so there's an oscillating circuit. Where the hell's the capacitor in the secondary, which is that longer coil shown over to the right there in that picture? And in this case, the toroid at the top, with the air around it, forms the capacitance. So what you get is a series resonant circuit, which is why changing the toroid size or its presence, you don't even have to have one, and the frequency of the secondary will go a lot higher. But yeah, so you do, even though you don't see it, there is actually a capacitor in the secondary circuit as well. So they look at this like tornado. It's not the size of the arc that matters; it's how you use it. Thanks. well said, tornado. All right, there's the Zap for today. I should mention that the Model 2 it's not tuned to resonance yet. It's not really done. It operates. It puts out about a 5-inch arc into air, a little longer to another object, even an ungrounded object, because of the difference in potentials. It'll throw maybe a 7 or 8 inch arc too. But once it's actually tuned properly, so that the primary and the secondary circuits are both resonant with each other, there should be lots of, how did we put it? Zap zap. Yes.
Lots of zap zap.
Lots of zaps, indeed. So, anyway, yeah, that's thus endeth my presentation. Back to you, Chief.
Nice. So, what are you using for a transformer? I'm using a neon sign transformer. I wasn't sure which road you had gone down with that.
Okay, I came across a source for some really cheap TV flyback transformers, which they're not in heavy demand right now because I don't even think you can get a television with a picture tube anymore. But it was the transformer that was responsible for putting the high voltage charge on the plates inside of a television screen to both focus and accelerate the electron beam. And since, like I say, they're just not in high demand by television manufacturers anymore. Supply houses are selling them for just a couple of bucks. I think the last batch of them I got 2 of them for $8 a piece.
Nice. And
those they give you a little feeder circuit with it too. That's how actually they got people to start buying them, because you do need it's called a flyback transformer because it operates in much the same way that a Tesla coil does. It's not just a turns ratio thing, and you do need a driver circuit for it. And if they had just sold the transformers, they wouldn't have had much luck. But apparently they had a stroke of genius and made these little driver boards where you get the whole thing, the driver board and the coil for $8. That's not too bad. And there you go. You've got an up to 40,000 volt low current power supply. You can run it anywhere between 12 and 20 volts. Obviously, you know me, so you know what I'm running it at. I don't really need to say I'm putting in 20.
Right.
Yeah. And 20 volts into the thing gives you about 40,000 out. And then it's the same. After that, it's the same circuit you're using. The flyback transformer feeds the cap. When the cap is fully charged, or charged enough to where it overcomes the breakdown voltage of the spark gap, then you get a blast through the primary coil. And that irregular triggering is what sets up an oscillation. And if that's in good resonance with the secondary coil, you get what we are now calling zap zap evermore.
Awesome.
So that's 1.21 gigawatt. Yes, Jason. That's something like that.
Now, I was trying to find the last transformer explosion, and I don't seem to have it any longer, so I may have to wait on that one unless somebody feels like digging through months-old Google Plus stuff, which I can't imagine. If I don't want to do it, I can't imagine anybody else does.
Well, that's I have heard of a lot of headaches with the newer the newer model neon sign transformers, just because there's a lot of protective circuits that it's supposed to be looking for ground fault problems or a dead short at the output. This circuit being that it's going through a spark gap by definition cannot have a short circuit because it's an open.
Exactly. Something happened with. I mean, like I say, the little warning LED is what exploded. So I don't know. I'm going to take the thing apart and we'll chase down the problem and get it running.
Yeah, just that which failed, don't fix, rip out. Just
yeah, I don't need a little light to tell me that something's about to go chaotic, because it's probably cycling on and off so fast that it just literally burned out the LED.
Besides, the goal here is chaotic, is it not?
Exactly. That's the whole point of high voltage insanity.
Indeed. So
we'll see. I'm also moving from the since the homemade capacitor decided it was going to try and start on fire. I did. Thanks for the link to those, by the way. I am getting some actual 10 kilovolt capacitors off of eBay, so we'll see if at least that will help prevent more fires from starting in the future with this thing.
Yeah, well, you went through the build your own cap thing, and it worked. We saw it charge, and
oh yeah, it was charging. It was doing a great job there. Which actually, that one's not far enough away on G Plus that should be able to at least pull that one up. On Friday night, I don't know why I had forgotten to do this, but I completely forgot to crimp my secondary coil onto my ground. So that's part of the reason why the capacitor was charging, the spark gap was firing, but nothing was coming out of the toroid at the top. Yeah. Don't forget to hook up your ground wire on your secondary.
Indeed, the first one I did, I only had a 2-wire. Oh, that's another thing. We did mention RF, right? In case we said it too quietly, RF. There's radio frequency activity going on. RF needs a good ground. My first attempts with the Tesla coil, it was. I mean, the spark gap worked properly. The capacitor worked properly. No arcing. Everything was good. When I fired it up, I was getting a spider web of arcing going down the outside of the secondary, and I was baffled. Like, what the hell is causing this? As it turns out, for ground, I was using the neutral for DC things and for DC projects and for 60 hertz AC projects. That's just fine. RF, however, needs earth ground. So the best thing you can do is a ground spike with heavy ground braid going to the thing. But as a close second, 3-prong, use the green wire. Use the real earth ground from your house wiring if you're going to do that. Because it took me a while to find that. I found no precedence for why there was a spider web of arcs climbing down from the top halfway down the primary. I'm in this halfway down the secondary. I could think of no good reason for that, and that's because with both a floating primary, which means neither side is grounded, and a floating secondary, the coil, since it wasn't working off of a ground, it assumed a virtual ground somewhere near the center, and both ends, the discharges from both ends were attracted to that. And it took a little research to figure out why the hell that was, but resolved finally. All right.
Very awesome. Well, it seems Stephen would like to see something go kaboom. So,
oh, lovely. All right, what do we have? That's you got anything over there? I gave you the G. Did I give you the link to the G drive?
You did.
I'll give it to you again if you need. If you have anything you want to throw up there now would probably... Here, let me get you the link.
Let's at least get the capacitor charging from the other night if anybody missed that from movie night.
All right, let me set this to... Here we go. Make you a folder. Anyone with the link can edit.
Yep, that's the right one.
All right, and here is... There. That's the G Drive link to your very own folder. What could be more exciting than that? All right, so it's not so exciting, man. that's what I got. Okay, I'll blow something up later.
I try to avoid blowing things up in general, but
oh yeah, we've seen. Like
because I try doesn't mean that I actually succeed.
I personally was entertained with the nothing blew up, but the path of fire in the backyard was very entertaining when you were doing spectroscopy. That was just great.
Oh, I didn't even upload the best one of those where I got some methanol on my foot and I didn't realize that it was on fire, so I just kept walking through the yard. Ooh.
To leave like little flaming footprints.
I did.
Oh, lovely. All right. Well, there you go. That's the G. If you have anything you wanna upload and have me put up, by all means, there you go. So
I don't know why in the world this isn't. Okay, let's go back to there. Things are being a little slow right now. Sorry for that.
Oh, we have a new visitor that wandered in. Great. Goldfish Overlord. Welcome. Glad you wandered in. Yes, this is Sunday Science. It's just about the opposite of movie night, where we're sarcastic and drunk for 5 hours. Here we're science-y for about an hour.
Usually right around an hour. Okay, why in the world can I not access this? This is really annoying. It'll probably be faster if you pull it off of the Backyard Science page.
Oh, all right. I will.
I don't know why in the world I'm not linking to this the right way. It keeps asking me, who do I want to be? Backyard Science or Andy? I want to be Andy right now. And I have no link to the drive, apparently, if I'm me.
Well,
that doesn't make sense.
That's odd. Oh, all right. You know what? Why don't we... Here's something. Let's see.
No, I don't want to be in my drive. I'm trying to use... What in the hell's happening here? This is retarded.
Not
Sorry, that's not a... Shouldn't... No. My bad.
Understood what you meant. Alright, what's with...
Let's see. I thought I put it on Backyard Science. At least get a capacitor charging.
Indeed. I'm looking for it now. Oh! Tesla coil cap being charged. Let's see.
Yeah, there it is.
How the hell do you... Wait a minute. How the hell do you download this?
I have no idea.
I don't see any option to do so. It's almost as if they don't want stuff burgled.
It's not burgling if I'm giving you rights to it.
I understand. All right. Let's see if I can get it up on the screen here.
All right, parts were working.
Actually, the audio from that was really the best part. Was it not? You really couldn't see too much. All right, maybe if I bring this window. All right, can you see it on the Andy, can here?
I'm just seeing the pug personally.
I should be presenting.
I believe you are.
And if I don't know, click on me. See if you can see the. Here, I'll stop and restart it. Doesn't always work perfectly. All right. Should have a black screen and the little play thing at the bottom, I think.
Well, I can't see it, but if other people can see it, hopefully.
Well, G Plus is a pain. Well, there's a good sound.
Right, everything was going well from the charging the cap and getting the spark gap to run. That was all going great, and then I wasn't getting any arcs for the obvious reason of not grounding my secondary.
And all right. God, I wish there was a way to download. You don't have the video there handy, do you? And oh wait, you couldn't access the.
I have it on my phone, but for some reason I can't.
If you hit that link for the G drive does not help you. Okay.
Yeah, I don't know what in the world's going on with that. The link you sent me keeps sending me to my G drive for some reason. That doesn't even make sense.
That's very odd. All right, let me.
Well, my phone's also horrifically broken, and it's been acting up pretty bad lately. I'm surprised the thing even actually turns on anymore.
All right. You know what? This is not working. Me presenting and showing the Hangout screen is basically just showing me. Why don't you? Do you have it up in G Plus? Why don't you present? And it'll show up here. Because that we can have show up.
Where's my screen? Just a window. Yes, that one.
All right.
It's a little weird without the sound.
Wait,
is this even?
Go ahead.
I don't think this is actually playing.
Go ahead, say it. Tap tap tap. Is this thing on? Tap tap tap.
Right. What in the heck? It's like the day of technical difficulties. Come on. There we go.
Oh, look at that. Hopefully sound will come through as well.
Hopefully. And in case there's no sound, yes, I dropped my phone.
Wasn't the best part of that one there was something similar to it? God damn it! At the end, was that when you dropped the phone?
Mm-hmm.
God damn it! All right. Well, anyway, and that was when Andy learned that the capacitor was charging just perfectly. That's what makes me think that what happened is you got some induced current from the fully operating coil. That made its way back to what was the output of your transformer.
Right, but, that's kind of what I'm guessing. or a ground fault issue, because it should be working just fine. I don't know why in the world that LED burnt out, but what a nuisance.
Yeah, well, the fact that you were able to charge the cap, and you did get the purple glow around the plates, right? Which,
oh yeah,
yeah. So it was charging. That's ionized air from a bunch of really annoyed electrons that they have to hang out right next to other electrons. That just pisses them off.
Right.
That's where you're getting a nice purple glow from. So we know that was working. We know the spark gap was working, and it was not until you added the oscillating circuit that's what took everything out. So,
yep.
Anyway,
I don't know. We'll figure it out. Obviously, there's some redundancies built into my neon sign transformer that I just need to go ahead and pull out because it's pretty useless. Doesn't need to be in there.
Really? All that safety nonsense. All that safety nonsense in the dumpster.
I'm trying to do something that is chaotic and erratic. I don't need a mechanism stopping the chaos and the randomness from happening. That's what I'm going for.
Absolutely. Uh-oh. Mark understands. Look at the chat. The smoke escaped. Yes, the smoke that makes everything work escaped from the circuit, so now the circuit is no longer functioning. Exactly.
I hate when the smoke escapes.
Absolutely. Anyway, but yeah, that is unfortunate. I can't wait till I get it. It is sort of a pain to get the thing tuned exactly to resonance, because with only you have what did you say, 12 turns on your primary? I've got, I think, 9. When you do that, you have to alter the capacitance so that you can use that primary coil to do the tuning by changing a clip, changing the length of the coil. And step 1 is bring it into the range so that you can do that with just the length of the coil. If you have not enough capacitance, you can't make you need longer. The coil needs to be bigger to lower the frequency to resonance. If you have too much capacitor, then you're all the way down at near 0 windings on the primary in order to get it anywhere close. But I've got the capacitance correct, and now it's just a matter of doing the tuning by moving the clip on the primary coil. And it's amazing to find the actual point of resonance. Movement of a couple of millimeters will either bring it into or move it off of resonance. So it's the fun part.
Right. Yeah, I'm looking forward to being able to get to the tuning part as opposed to the billowing smoke part.
Alan says the smoke's not so bad. It's when the flames come too, you have to worry.
Right.
Especially when removing power does not remove the flames. I've been there. Alan, I name you experimenter. You've obviously done this before too.
Indeed. And it's obviously, it's not the transformer. It's very obvious that it's just that LED. It burned up and now it's melting and burning and smells disgusting. I know my transformer's fine. I gotta get rid of the junk that keeps it from being dangerous.
Indeed. Oh, well.
I don't advise that for anybody building a Tesla coil, but hopefully if you're building a Tesla coil, you already know that there's going to be some safety measures that are, yeah, we'll just leave that one there.
Yeah, that is
high voltage capacitors, don't get close to them.
Oh, yeah.
Ever.
Yeah, absolutely.
Ever.
And, and when you're done doing whatever it is you're doing, discharge it. And then when you're done discharging it, discharge it again.
Discharge it again.
Because with with these plate type capacitors, really one discharge, it's all out. They're very fast. It'll all the available current will be delivered immediately in most cases.
Yeah, I suggest if you're going to build your own capacitor, make sure that you have a resistor that can discharge it safely, because dropping a screwdriver on 21 kilovolts is not the best way to discharge this kind of a this kind of a capacitor.
Oh, no, now you tell me. Thanks, Chief. Thanks. Anyway,
well, you know, but, I had to say it at some point.
He's quite right, because these plate capacitors, where it is purely the charge that's holding it's the opposing charges, the absence of electrons on one side of the insulator and the overabundance of electrons on the other, that keeps the charge in the capacitor. So when it's discharge time, they're perfectly happy to all split at once. In other types of capacitors, the various electrolytics and things of that sort, they still will put out most of their current pretty quick, but not all of it. Capacitors have different speeds based on what they're made of, what materials they're composed of. So that's safety first. Discharge it when you're done fiddling with it, and then the next time you're going to use that capacitor for anything, discharge it before you start to handle it.
Oh yeah,
it's nothing like having numb hand for a week.
Oh yeah, I got one for another project that I can't wait to use the thing. It's a 350 farad 2.7 volt super cap. That thing is going to be awesome.
Yeah. Okay.
That's the worst game of hot potatoes you could ever imagine. It's only the size of a D-cell battery, so
yeah. Anything, you got to be careful what you hook it to. Fortunately, that's below what is the galvanic response of skin? I think, what is it? 35, 40.
I can't remember off
something. Yeah. It's something. It's not. It's not 20 or 30 volts. I know it's higher than that, but. Oh look! Yeah. apparently Sue has done a little bit of experimenting as well. That is something I have not tried. And did you see?
I kind of want to try that now.
Oh yeah, Mark, that makes sense. A longer screwdriver and more tape on the end. That would do it. And
I still like the route of using a resistor.
It is the best way, and you can obviously a lower value resistor, you'd have to have a 4, 5, 10 watt resistor, but up in the you use a 1 mega ohm. Yeah, it'll take a little longer to discharge it, but you just leave it connected and put the thing on a shelf, and it will discharge it.
That's why you take apart your computers when you're done having it be a computer, so you can break into the power supply for all the goodies.
Indeed.
There's a treasure trove inside a PC power supply.
Absolutely, and even the power supplies are pretty damn useful, even though they're switching supplies, and generally for projects such as these where you're really beating on the things. It's expected that you would have just a regular coil wound, step down or step up power supply depending on what you're using. But if you throw a fair amount of capacitance at the output of the computer power supply, you can make it act just like a regular wire wound transformer power supply, and they're quite useful and cheap.
Indeed.
How many people just thrown out? Anyway,
thrown out all over the place. Yeah.
but we digress. And all right. Well, Chris just joined. He's thinking things are cool. All right. Andy and I were talking about possibly a how-to for anybody that wanted to make their own Tesla coil, starting with what's called the Slayer circuit, which is the circuit you see now is a spark gap Tesla coil, and there's no question about it. It is a hazardous item to have. It will kill you. Yes, you can kill yourself with this. It's
oh yeah.
So we figured a good start.
The whole thing that it's the amps, not the volts. When the volts are high enough, the amps don't need to be that high either.
Yep. Plus, we got a capacitor involved. So in this circuit, you actually have both high voltage and high current. So,
it might not be high current coming off the toroid, but
no, high current
coming out of the capacitor, that's got some movement to it.
Yeah, 20,000, and that thing discharging instantly would be up in the at least 8 to 10 amp region. So
at least,
yeah. Oh, Jason wants a how-to. Okay, all right. There's a vote. There's a vote in the affirmative. Nice.
Excellent. I say we make a how-to then.
Very good. And you like the Slayer circuit? It's very simple. Uses all low voltages, nothing lethal. I mean, unless you eat the thing, it really can't hurt you. And then and there's stuff you can do with it. With this, people have asked, can you do the music? I'm sure everyone has seen the Tesla coils that play music by modulating the output frequency with a superimposed audio frequency. There's no good way to do that in a circuit that you're feeding with 14 kilovolts. You need to superimpose audio out of an amplifier that's putting out similar wattage to what you're putting into the primary. So it's almost impossible with this kind of circuit. With the Slayer, which is the Slayer circuit, it's called. The whole thing operates between 12 and 20 volts, and after you make it and it functions and you're happy with it, it's possible to do a phase 2 where you just get a small audio transformer, costs about $1, and you can feed audio into it and have, like you've seen on the internet, have your Tesla coil play music at you. So anyway, yeah, how-to sounds fun.
Definitely.
Jason likes the names. Slayer circuit. There'll also be for any of you old timers out there, there'll also be a Motley Crue circuit, and an Ozzy circuit. But we're going to start with the Slayer circuit.
Oh, that's awesome!
All right, and you specifically told me to save the corny jokes for movie night. How do you? All right.
No. Science has always got to have some corny jokes in it. What would you do without it?
That is true. I suspect it's the puns that keep us alive.
Indeed, without the corny jokes, there would just be a lot of frustration in math, and that would suck.
And fire.
Well, yeah, the fire part's still cool, so
yes.
doesn't get tossed in with the things that suck.
Absolutely.
Too much math, yes. That as much as I love math, too much math will wear you out real fast.
Mm-hmm.
And trying to stick to perfect calculations when it comes to trying to build something will drive you insane. Just put the damn thing together.
Oh yeah, especially in circuits such as this. That's similar to yes, you can do all the math ahead of time, and it'll get you in the range. It'll get you close to resonance, but you will not hit unless you're unbelievably lucky, because yes. Go ahead.
Sue, technically a Tesla coil is an AC/DC circuit.
See,
I think you just won.
Hey, so
do you have
I forgot.
Oven mitts left? You might be able to send Sue an oven mitt.
We have some.
Backyard Science doesn't really have anything to.
We got to make some giveaways for Backyard Science. That's something cool.
Indeed.
Something cool and non-lethal. The answer to yes, we do have some of the mitts left. Actually, I had them here. Remember that little period I told you about when it got sub-zero here and the upstairs circulator?
Oh,
yeah, and water went from... You know how, like, when the smoke escapes, the circuit doesn't function anymore? Well, when the pipes burst and the water escapes, the heat doesn't work anymore. And often it finds its way down to the first floor and soaks a box of mitts.
Oh, no.
I can't believe I was just speaking to the box of mitts as if it had done something wrong. Anyway, fortunately, that is not the That that is not the only box. That was just some. Anyway, so yeah, AC/DC. I can't believe I didn't think of that. That's beautiful. All right. You know what? Why don't I throw the link up there so she knows what to do? Get the link first. Here we go.
Oh, and I should say congratulations, Sue. You're getting an oven mitt before even I got an oven mitt.
Here we go. I will put the link up there.
There's a reason why anytime Jonathan Evan makes a new movie, I'm sitting there going, God, my hand and my forehead hurt.
All right, there's a link. And remember, YouTube botches links. There's going to be some invisible characters at the end. You might have to, after you might have to copy the link, put it into the browser, and then see if YouTube has injected some non-printables at the end. Otherwise, just go to SciStrike.com and look for prize winners. That's where that link takes you. So, congrats. You have an oven mitt. And there we go. Let's get back here. Okay.
Well, I think that's about all I got. I really want to start tearing this thing apart so I can get rid of the safety jargon, because I'm not okay with safety jargon.
Well, it's
overkill.
In its intended circuit, it's fine. It just this is not this is not the intended circuit.
Yeah, I'm not trying to make a sign light up. I'm trying to make bolts of lightning explode out of an aluminum donut at the top of a copper stick.
Indeed. What's wrong with the people that made that transformer? How could they not foresee that?
Right? They should know that half the time they're making one of these, double tap transformers, that it's not going to power a sign. It's going to wind up in someone's basement or garage or backyard tinkering shed doing everything that their safety precautions are going to prevent it from doing.
Indeed. Quite true. All right. Well, all right. So we got to put together a how-to show. So, folks. Okay, Sue, that's the link's getting botched. Just go to SciStrike.com and you'll see one of the menu options is prize winners. And just and then we compare that to the list and out they go. As soon as I can take my lazy ass out to the post office, which will be. And SciStrike.com, I think you can get to, assuming I remember to pay the renewals for the domain name, which I think I did. Let's make sure, shall we?
Right, we'll find.
SciStrike.com. Yeah, okay, yep, that works. And yeah, and 1, 2, 3, 4, 5 prize winners is the 5th tab over. Fill out the form and winner. We should have a little bell for that, shouldn't we? All right. Oh. Okay.
Well, that's all I have for today. Hopefully I will have my Tesla coil up and running here pretty soon in the next day or two once I figure out this safety thing, which obviously I already burned up the safety thing, so what good does it do? It just melts and starts pouring putrefaction of plastic smoke everywhere. That's not a safety mechanism. That's a death switch.
No, bursting into flame is hardly what I would call safety.
Right. If it just overloaded and shut down, okay, fine, whatever. There's an internal circuit breaker. Let's just pull that out and get rid of it. I'm going to ignite on fire and billow smoke? That's a terrible safety mechanism.
I would tend to agree. Uh-oh. We did Jacob's ladders. All right, we'll have some videos of the Jacob's ladders in a future thing as well. But yes, we've both of us, both Andy and myself, have constructed Jacob. That was in the train of high voltage experimentation. Yeah, see,
Indeed, the last one actually that I built is the double helix, so you have a nice little spark climbing up a copper DNA looking molecule. It's pretty cool.
I would say so. All right. Well, we will. We'll have
Don't
to.
worry, Jason. I will not lose the magic black smoke.
All right, we'll include, because that was really on the path. We both did those first before moving on to different high voltage experiments like the Tesla coils and all that. So we should.
Yeah, the Van de Graaff we're going to have to go over. I'm pretty curious about building a Van de Graaff because, as anyone knows from previous episodes, Van de Graaff generators were originally the whole initial point of the Van de Graaff generator was actually an early particle accelerator. So, not saying I'm going to build a particle accelerator, but I definitely think I need to build a Van de Graaff generator.
Well, it's an interesting thing, and it operates on a very unusual. Look at this, we're going into overtime. All right, we'll bring back the Tesla coils and go over that theory as well.
We're just going to have to wait for another episode.
It is a very interesting theory of operation. It's completely different than just this voltage amplification through resonance in the Tesla coil or just a transformer. It is very interesting, you're right. And, Wisdom Vendor, absolutely. Electro Boom, I find very entertaining. He's
oh, yeah, Electro Boom's hilarious.
Absolutely. I do get a kick out of that. And he's done some Tesla stuff as well. And it's only in his last one that he hinted at the resonance. I guess was doing it in successive, successive spots on the Tesla coil. He didn't want to hit people with RF theory day one, but that was the first couple I watched, and it was about, he mentioned the turns ratio and all that, and wait a minute, no, that's not where no. And then I saw the last one, so I think that's what it was. But yeah, we love that channel.
Oh, yeah.
All right.
Always good stuff.
Absolutely. Okay.
Well, I suppose we might need to have a second round of high voltage episodes because it doesn't seem like we actually got through everything, but we are up on the hour.
That we are, and there's much more to do, so we'll just see you all next week, I guess.
Indeed. Thanks for joining us, everybody. It's always a blast, and hope you guys enjoyed.
I see what you did there. It's always a blast. Thanks for coming, everybody. We'll see you again. See you next week. And thanks, Andy. Good show.
Glad I could be a part, and this has been a lot of fun running Sunday Science. It's just a lot of fun.
And if I didn't have to be here running the computer, I'd be here anyway watching. So on that note, all right.
Awesome.
Good night, Andy. Good night, everybody. Thanks for joining us.